Oxides. This is a group of compounds in chemistry made up of an element combined directly with oxide ion. O is the symbol for oxygen atom. Chemically, oxygen atom is unstable. It belongs to group 6A, meaning that it has 6 electrons on its outermost shell, which means for it to be electronically stable, it needs additional 2 to be in octet configuration. So if we give oxygen atom 2 electrons, it becomes charged 2 minus. This negatively charged oxygen is what is called oxide or oxygen ion. Now, this oxide, any binary compound that contains this oxide ion is called an oxide. It belongs to this group. Binary compounds are compounds that contain 2 elements. So, for instance, sodium ion combining with oxide ion, we form a binary compound. Sodium, 1 plus goes to oxygen, 2 minus comes to sodium, and we have Na2O. This is an oxide. Why? It is made up of 2 elements, sodium and oxygen, and one of the ions there is oxide ion. That is why it is an oxide. These are the types of oxides: acidic oxide, basic oxide, amphoteric oxide, neutral oxide, higher oxide. Higher oxides are classified into peroxide and other higher oxides. Acid oxides. These are oxides of nonmetals. That is non-metallic oxides like NO2. You see that the non-oxygen atom there is nitrogen, and nitrogen is a non-metal. We also have CO2. Carbon is a non-metal. So all the oxides of non-metals, not all, but some oxides of non-metals are acidic. Why are they called acidic oxides? Because they neutralize a base to form salt and water. And also, they can be called acid anhydrides. Acid anhydride means any oxide that produces acid when dissolved in water. Hydride means water. So, acid anhydride means yielding acid when dissolved in water. Examples are NO2, nitrogen 4 oxide, CO2, carbon 4 oxide, SO2, sulfur 4 oxide, SO3, sulfur 6 oxide. All these are acid anhydrides or acidic oxides. Why? They can dissolve in water to produce acid. For instance, CO2 can dissolve in water to produce H2CO3, which is carbonic acid. They can also react with a base to form salt and water. For instance, the same CO2 can react with sodium hydroxide base to form sodium carbonate, Na2CO3. That is sodium reacting with CO2 and O, carbonate, plus water. To balance the equation, sodium is 2 this side, you write 2 here. Oxygen is 2 plus 2, 4. 3 plus 1, 4. So it's balanced. Basic oxides are, unlike acidic oxides, they are oxides of nonmetals which neutralize an acid to form salt and water. The ones that are soluble, the ones that can dissolve in water, when they dissolve, they form an alkalis or alkaline solution that can turn red litmus paper to blue. Examples of basic oxides are sodium oxide. Remember, sodium is a metal. We also have magnesium oxide. We also have calcium oxide. We also have potassium oxide, etc. All these oxides of nonmetals, which neutralize acids or dissolve in water, as the case may be, to produce alkaline solution. They are basic oxides. Okay, let's see how sodium oxide reacts with an acid. Let's use HCl, hydrochloric acid. It will react with this acid to form salt and water. Sodium will react with chlorine, and we have sodium chloride, which is a salt. And oxygen will react with hydrogen, and we have water, which is also a salt. Sodium is 2 here, so we write 2 here to balance it. Chlorine is 2, hydrogen is 2, we write 2 here to balance it. This is how basic oxides neutralize acids. Now let's see how basic oxides produce alkaline solution or alkalis. Sodium oxide will dissolve in water and produce an alkaline solution or alkalis, sodium hydroxide alkalis. When it produces sodium hydroxide alkalis and you put litmus paper, the solution will turn, the litmus paper, red litmus paper will turn to blue. So this aqueous solution of a base, alkalis. To balance the equation, sodium is 2 here, you write 2 here, oxygen is 1, 2, and it's 2 here, hydrogen is 2 and 2 here, balanced. Amphoteric oxides is gotten from amphi, which means dual behavior. Remember, amphibians that live part of their life in water and part on land. So amphoteric oxides behave both as acidic oxide and basic oxide. They are oxides of metals close to the metalloid borderline on the periodic table. This is the periodic table, and this side is made up of metals, this side non-metals. This borderline is made up of metalloids, those that behave like both metals and non-metals. So amphoteric oxides are oxides of elements that are very close to this borderline. Being very, very close means that they behave partly as the non-metals and partly as the pure metals. They are almost metalloids. That is why their oxides behave both like acidic oxides of non-metals and basic oxides of metals. They are oxides of aluminium, zinc, tin, lead, etc. So they are oxides of aluminium, zinc, tin, lead, etc. So what do? They react with both acid and base to form salt and water. The pair of equations show the amphothericity of zinc oxide. Here, zinc oxide behaves as an acidic oxide by reacting with a base in the presence of water to give a complex salt. Aqueous, there is water inside there. Here, the same zinc oxide is acting as a basic oxide by reacting with an acid to form salt and water. Neutral oxides are oxides of non-metals also. They are non-metallic oxides that neither react with acid nor base. This one, they can't neutralize acid, they can't neutralize base. They are neutral to litmus paper. They are oxides of hydrogen and also oxides of carbon and nitrogen at their lowest oxidation states. These are the elements we are talking about. We have hydrogen. Hydrogen has 2 oxidation states, H minus and H plus. But in this case, H minus cannot react with oxide, which is 2 minus. Minus cannot react with minus. We are focusing on positive oxidation states. So the positive oxidation state of hydrogen that forms neutral oxide is H plus. Carbon has 2 positive oxidation states, 2 plus and 4 plus. But the lowest here is carbon 2 plus. Nitrogen has many positive oxidation states, but the lowest positive oxidation state is plus 1. So these 3 are the elements, the oxidation states that form neutral oxide. For instance, H plus reacting with oxide ion will give us H2O. So water is a neutral oxide. C2 plus, when it reacts with oxide ion, 2 minus 2 plus we cancel, we have CO. So carbon 2 oxide is a neutral oxide. N plus, when it reacts with O2 minus 2 comes here, 1 goes there, we have N2O, that is nitrogen 1 oxide or laughing gas. These are the 3 most popular neutral oxides. Higher oxides are oxides that contain higher proportion of oxygen than normal. For instance, sodium oxide is not a higher oxide, it's just a normal sodium oxide. But when we have Na2O2, it has a higher proportion of oxygen. So this is called sodium peroxide. It's an oxide. So there are 2 classes of higher oxides, peroxides and other higher oxides. Peroxides contain peroxide ion, that is O2, 2 minus. They react with dilute acid to yield hydrogen peroxide. That is why they are called peroxides. Other higher oxides don't react with dilute acid to yield hydrogen peroxide, but when heated, they produce oxygen. So they are oxidizing agents. Examples of peroxides are sodium peroxide, calcium peroxide, magnesium peroxide, potassium peroxide, etc. When calcium peroxide reacts with acid, let's say H2SO4, it will yield calcium sulfate plus hydrogen peroxide. That is why calcium peroxide is a peroxide. It yields peroxide when it reacts with dilute acid. Examples of other higher oxides, they are lead 4 oxide, not lead 2 oxide, PbO, Now, lead 4 oxide. We also have manganese 4 oxide. Yeah. We also have iron 2 diiron 3 oxide. Iron 2 diiron 3 oxide. These are other higher oxides. So that is the end of the class. We started by defining oxides as binary compounds that have O2 minus ion. And we classified oxides as acid oxide, basic oxide, amphoteric oxide, neutral oxide, and higher oxides, which are classified into peroxides and other higher oxides. I hope you got value. If you did, kindly subscribe to my YouTube channel.